Alright guys, here's the first day of your college algebra notes. So hopefully this goes well. We have chapter R, which is a review chapter of what you should know before you go into college algebra. I think you guys will do fairly well with it, but we'll see. And if you have questions, always feel free to come in and ask me. College algebra should be a review of all 3 years of your high school math, as well as going a little deeper. So nothing should be a new topic. But if it is, maybe we just don't remember or whatever. But we'll deal with it when it happens. So, the first part of the review chapter is giving you an expression. It wants you to plug in values for the variables and come up with a numerical value that is equivalent. So, if we have 5x plus y and x is negative 5 and y is 4, let's plug in for x and y. So we have 5 times negative 5 plus 4. I put negative 5 in x's spot and 4 in y's spot. So then, to simplify, I do order of operations. So I get negative 25 plus 4, and I get negative 21. I did multiplication first rather than addition. Go ahead and try the other two. Pause the video. When you're ready, replay it, and you can see if you got the answers right. So what I did was negative 6 times negative 5 minus 9 times 4. So 30 minus 36 is negative 6. For this one, it's the absolute value. That's not going to change anything. We're still going to put in negative 5. We're still going to put in 4. We still multiply first. Then we still do subtraction first, or next. And then we worry about the absolute value. What is the absolute value of negative 23? Well, the question really is, how many units is negative 23 away from 0 on the number line? And that is 23 units. So that's why you get positive 23. The next part of the chapter is dealing with domain. Domain is what values can your x function, or what values for x can you possibly put into a function. It's all the possibilities. So usually we have all real numbers, or negative infinity to infinity for linear, quadratic, and cubic. However, this is a rational because it's a fraction, and we learned in World of Functions that 0 you can't divide by. So we want to figure out what makes x 0, or what value of x makes our denominator 0. So when will that be 0? So if we solve for x, we would get 5x equals 5, so x equals 1. That is a bad number. X can't be 1 because then you'd be trying to divide by 0, and you can't divide by 0. So we're going to say negative infinity to 1. We're going to put parentheses because we are not going to include it. And we're going to go 1 to infinity. Here, we got x squared minus 25. So go ahead and try that one. Most of you probably said 5. Yay, go you. However, there's another value that when you square it, it becomes 25, and that is negative 5. So you got two bad boys there. So from there, you go negative infinity. Negative 5 comes on the number line first. Then we go negative 5 to 5. We can't go negative 5 to infinity because you have to stop at 5 and show that there is something going on there. And then we got 5 to infinity. So here you had two bad guys, 3 sets of parentheses, 1 bad guy, 2 sets of parentheses. From there, what we're going to do is exponents. So we have some exponent rules. Our negative exponent rule says if anything is to a negative exponent, you simply put it in the denominator and make your exponent positive. Then we have if two things are being divided by each other and they have the same base, what you can do with their exponents is subtract them. Then we have if two quantities are being multiplied by each other and their bases are the same, you can add your exponents. Then we have if we have a power to a power, so parentheses, you multiply your exponents. Oops, I said add up here hopefully, and I multiplied when I rewrote it. So add, multiply, don't get those confused. The other one is if you have two things being multiplied and taken to a power, you distribute that power into your parentheses to all the parts that are there. I think that's it for now. So here we have 4 to the negative 2. So that falls under our negative exponents because you cannot have negative exponents. So we're going to rewrite it as 1 over 4 squared. Some of you are like, hello, I'm going to type it in my calculator. Great, go you. You cannot leave it as a decimal. So convert it to a fraction, which is 1/16. Here something squared, that doesn't need any properties rules. That is just that number. So here we got two things being taken to a power. So we're going to do product to a power, as well as we have powers on those already. So we're going to be doing power to a power. So I'm going to distribute the squared to this x and to the y. And I'm going to do that by multiplying my exponents. So I get x to the fourth and y to the negative 2. We got a negative exponent. Can't have a negative exponent. So we simplify, keep x on top because it was positive, put y down below because it is negative. Notice when I put it down below, it became a positive exponent. Here, we're going to just get rid of our parentheses, so negative 2 cubed is negative 8. X to the fourth. Here we got two quantities being squared, so y squared, z squared over 9, because 3 squared, and x, y cubed times z. No negative exponents and no fraction or no decimals, so go us. However, we have x appearing more than once and y appearing more than once in z. You can't have your letter appearing more than once. 3 rules. No decimals, no negative exponents, and the letter cannot appear more than once. So let's fix that. So we're going to use our subtracting law because we're dividing x's. So we got negative 8 x cubed because I subtracted, y negative 1 because I subtract 2 and 3, and z to the first because I subtract 2 minus 1 over 9. The coefficients do not change. You do not subtract those. You keep them as division. 8 ninths is not negative 1 or whatever. So keep that as itself. Don't jack with the coefficients. So here we have fraction. We have x appearing once, y appearing once, z appearing once. However, we got that negative exponent. So I'm going to move the y to the bottom, and we are going to get negative 8 over 9. X cubed stays up top, y goes down with the 9, and z stays up top. And there you go. The negative 8 does not move. It is a coefficient, so do not move your coefficients. And last but not least, we are going to add, subtract, and multiply different polynomials. So when you add polynomials, you add like terms. So we got x cubed. There's only one of them. We have some x squares. So here we got 2, here we have 1, since we're adding, we get 3. Here we got 2, here we have 4, so we get 6. Here we have negative 4x, it's a lone soldier. Do you have to write it in descending order? Of course not, but when I do mine, I will. Here we're going to do subtraction, so go through and find common terms. We got x cubed, nothing else to go with it. We got 2x squared minus x squared is 1x squared. You have to put the 1. No. We have 2 minus 4 is negative 2. And then we have minus negative 4x. This is where people will jack up and they'll still put minus 4x. However, minus a negative is plus 4x. Here we have 1, 2, 3 terms times 1, 2, 3 terms. So trinomial times a trinomial. Anytime you have multiplication, you are going to do a lovely area model. So I'm going to put my first set of parentheses on top and my second set on the side. And from there, complete your area model. So x to the fifth, I add my exponents. It doesn't have parentheses, so I don't need to multiply. We've got 2x to the fourth, 2x squared, negative 4x to the fourth, negative 8x cubed, negative 8x, 4x cubed, 8x squared, and 8. So, from there, we're going to combine like terms. Usually it's your diagonals, but if you notice, this one's squared and those are cubed, so you're going to have to watch that on this one. So we got x to the fifth, negative 2x to the fourth, negative 4x cubed, 10x squared, negative 8x, and positive 8. All of these notes can be viewed online, just the notes on my website. Just click on January 4th and it will pull them up. Hopefully you took good notes today as well, and you will be able to use them in class on the 4th and get your homework done in class. So have a great Christmas break, And I will see you all back on the 4th.